All right. Let's crack open the world of machine learning. This deep dive, it's really for anyone who's maybe just starting out with ML.
Yeah.
We've got a whole bunch of these Microsoft Azure training documents.
Oh, cool.
And honestly, they are amazing. Really, it's like machine learning 101.
Nice.
But way more engaging.
Yeah. The goal is really to make this whole complex field,
Totally.
accessible.
And the coolest thing I think about machine learning is like having this, crystal ball.
Yeah.
But it's powered by data.
Mm-hmm.
We're using what we know to kind of predict the future, right?
Exactly.
Like, say you could predict how many pizzas a restaurant's going to sell.
Yeah.
Based on like the day of the week or the weather.
Mm-hmm.
That's the kind of power we're talking about.
That's it. And it's not magic, it's math.
Right.
The documents that we have here, they dive into two main types of machine learning.
Okay.
Supervised and unsupervised.
Right.
So with supervised learning, think of it like teaching a dog a new trick. You show them what to do, you reward them when they get it right.
Yeah.
And eventually they kind of learn the pattern.
So we're giving the computer examples with like the answer's already there.
Yes.
And it's figuring out the relationship between the input and the output.
Yeah. So for example, let's say you're trying to predict whether a customer will click on an ad.
Okay.
Based on, their browsing history.
Mm-hmm.
You feed the algorithm examples of their past browsing and whether they clicked or not.
Okay.
That's your labeled data.
Got it.
And then the algorithm learns from that to predict future clicks.
That makes sense.
Yeah.
The documents also talk about different flavors of supervised learning, regression, and classification.
Yeah.
What's the difference there?
Okay, so think of it this way.
Okay.
Regression is like predicting the temperature tomorrow.
Okay.
You're trying to predict a number on a continuous scale.
Okay.
Classification is like predicting will it rain or not tomorrow.
Oh, okay.
You're choosing between distinct categories.
Got it. So regression for numbers,
yes.
Classification for categories.
Exactly.
Okay.
Yeah.
Our source material uses this example of predicting ice cream sales.
Okay.
Based on temperature.
Mm-hmm.
Would that be regression then, since we're predicting like a quantity?
You got it. You could plot that data,
okay,
temperature, on one axis, ice cream sales on the other.
Yeah.
And a regression algorithm would basically draw a line that best fits those points.
And then you use that line to predict ice cream sales for any given temperature.
Yeah.
That's really cool.
And there are ways to measure how well that line fits the data.
Oh, okay.
Think of it like a scorecard for your predictions.
Makes sense.
Mm-hmm.
What about classification?
Yeah.
What are some like real world examples of that?
Oh, there's tons. Think spam filtering.
Okay.
The algorithm learns to classify emails as spam or not spam.
Right.
Based on the sender subject line, the content.
Yeah.
Or even image recognition.
Okay.
An algorithm identifying objects in pictures. Classifying them as a cat-dog car.
So classification, it's everywhere.
It is.
Seems like it'd be super helpful for decision-making in all sorts of fields.
Absolutely. But let's not forget about unsupervised learning.
Right.
That's where we don't have labeled data.
Okay.
It's like giving someone a jigsaw puzzle with no picture on the box.
Oh, wow.
They have to figure out the patterns themselves.
So it's more about discovery than prediction.
Yeah.
Like finding hidden groups or structures in the data.
Precisely. Think customer segmentation.
Okay.
An unsupervised algorithm could analyze purchasing patterns and group customers together based on similar behaviors.
Gotcha.
This helps businesses target their marketing more effectively.
So even without knowing the right answers beforehand, we could still get valuable insights from the data.
Yeah.
How does the algorithm do that, though?
How does it find those hidden groups?
Yeah.
One common technique is called clustering.
Okay.
It's like grouping socks by color. You're putting similar items together based on shared characteristics. For customers, those characteristics might be their purchase history, their demographics, or their browsing behavior.
So it analyzes those features and tries to find those natural groupings.
Yeah.
That's really cool.
It's used in recommendation systems, anomaly detection, even gene sequencing.
Wow.
The possibilities are kind of endless. But let's move on to something even more mind-blowing.
Go ahead.
Deep learning and neural networks.
Right.
This is where things get really interesting.
Okay, I'm ready. I've heard so much about deep learning, but it's always seemed kind of intimidating.
Yeah.
Break it down for us.
Okay.
What are these neural networks all about?
They're like the rock stars of machine learning.
Okay.
Imagine a network of interconnected brain cells.
Okay.
That's essentially what a neural network is.
Got it.
But instead of neurons, we have mathematical functions. They're designed to mimic how our brains process information.
So it's like a computer brain that can learn and adapt.
Exactly.
Wow.
Neural networks are really good at these complex tasks, like image recognition, natural language processing, and even playing games like chess and Go.
That's incredible. But how does a neural network actually learn?
Yeah.
Like, is it like teaching a dog a trick?
It's a bit more complicated than that.
Okay.
Neural networks learn by adjusting their internal parameters.
Okay.
Think of them as like knobs and dials to minimize errors during training.
Got it.
It's a process of trial and error, but at a massive scale.
So like fine-tuning a really complex machine.
Exactly.
To get the best possible output.
And the more data we feed the network, the better it gets at finding those patterns and making accurate predictions.
This is so fascinating.
Yeah.
I'm starting to see why people get so excited about machine learning.
Yeah.
It's like we have this powerful new tool for understanding the world.
Exactly.
But how do we actually use these tools?
Yeah.
Our source material mentions Azure machine learning. What's that all about?
Azure machine learning is like a toolbox for building training and deploying machine learning models.
Okay.
It provides all the resources you need from powerful computing power to pre-built algorithms and intuitive interfaces.
So it's like a one-stop shop for all your machine learning needs.
Exactly.
That's amazing. But I have to admit, I'm not really a coding whiz.
Okay.
Can I still use Azure machine learning?
Absolutely. One of the coolest things about Azure ML is that it offers a visual drag-and-drop interface called Azure Machine Learning Studio. Okay. You can build and train models without writing code.
Wait, seriously?
Yeah.
That sounds way less intimidating than I thought.
Yeah.
Tell me more about this studio thing.
Think of it as a playground for machine learning.
Okay.
You visually connect these different modules, which represent algorithms, data transformations, evaluation metrics to build your machine learning pipeline.
It's like building with Legos, but for data science.
Wow. This is blowing my mind.
Yeah.
So even someone with limited coding experience can build these sophisticated models.
Yeah. Azure Machine Learning Studio makes machine learning accessible to a wider audience.
That's fantastic. I'm already seeing potential applications in my own work.
Yeah.
But before we get too carried away, let's take a step back and revisit some of the key things we've talked about.
Yeah.
This is a lot to take in.
It is.
I want to make sure I'm following along.
Right.
Let's recap what we've learned so far.
Okay. So welcome back. Glad you're ready to learn more. Let's jump back into machine learning and check out some of these tools.
Okay, I'm excited. We were talking about Azure Machine Learning Studio and how it makes building models easier.
Yeah.
It's almost like it's doing the hard work for us.
It does a lot of the heavy lifting, for sure.
Yeah.
Especially with this feature called AutoML.
Oh, yeah, AutoML.
So imagine you're trying to predict customer churn.
But you don't know which algorithm is best for the task.
Right.
AutoML comes in and kind of takes the guesswork out of it.
Oh, so instead of me having to like research and experiment with tons of different algorithms, AutoML tests them out for me.
Yeah. It tries out a variety of algorithms, like those logistic regressions and decision trees we talked about.
Okay.
And then it compares how well they perform.
So it's like having a personal trainer for your machine learning model.
Exactly.
Pushing it to be its best.
That's the idea. And once it identifies the top performer, it even fine-tunes the settings to squeeze out the best possible performance.
That's incredible. It sounds like AutoML would be a game changer.
Yeah.
For people who are new to machine learning.
Yeah, it really lowers that barrier to entry.
Right.
But even if you want to go deeper and learn those algorithms, AutoML is still great for quickly testing ideas.
Makes sense.
Thanks.
Speaking of going deeper, let's talk about those algorithms a bit more. Can we unpack logistic regression and decision trees?
Absolutely. So logistic regression, despite the name, is actually a classification technique.
Oh, interesting.
It's often used for predictions involving yes-no outcomes.
So like predicting if a customer will click on an ad or not.
Exactly. It calculates the probability of that event happening.
Okay.
The probability of them clicking based on some input features.
So it's giving us like a percentage chance.
Exactly.
Oh, okay.
Like there's a 75% chance this customer will click.
Got it.
And then you can decide whether to show them the ad.
That makes sense. So that's logistic regression.
Yeah.
What about decision trees?
Okay, so decision trees?
They sound a little bit more intuitive to me.
Yeah, think of them as flowcharts for making decisions.
Okay.
Imagine a tree with branches.
Yeah.
Each branch represents a decision based on a feature.
So if we're trying to predict if someone will buy a product, one branch might be like, is the customer's age greater than 30?
Exactly. And you keep following those branches until you get to a leaf, which represents the final prediction.
So in this case, will buy or won't buy.
Yeah. It's like a game of 20 questions.
Yeah, like you keep asking questions.
Right.
Based on the answers you get until you arrive at the final answer.
That's a great analogy. Decision trees are popular because they're easy to understand.
Yeah, they seem pretty straightforward.
And visualize.
But I imagine there are situations where they might not be the best choice.
True for really complex problems with tons of features and relationships.
Yeah.
Decision trees might not be complex enough
to capture it all.
Right.
So what do we use in those cases then?
Well, there are lots of other algorithms out there, each with strengths and weaknesses.
Right.
One that's used for complex classifications is a support vector machine, or SVM.
I've heard of those, but they sound kind of intimidating.
Okay. So
can you explain it in a way that even I can get?
Imagine you have data points representing two categories.
Okay.
Let's say cats and dogs.
All right, cats and dogs.
And SVM tries to draw a line that separates them as cleanly as possible.
It's like drawing a boundary.
Exactly. But instead of a simple line, it's a more complex shape in a higher dimensional space.
Ooh, higher dimensions.
Think of it like a curved fence that perfectly separates the cat points from the dog points.
That's a cool visual.
So when we get a new data point, we can see where it falls.
And predict if it's a cat or a dog.
Exactly. And the goal of the SVM is to find that fence that creates the biggest gap
between the two.
So we can be more confident in our predictions.
Okay, that makes a lot of sense.
Yeah.
So we've got logistic regression for predicting probabilities.
Yes.
Decision trees for those flowchart style decisions. And support vector machines for drawing boundaries.
Yeah.
It's like we're building a whole arsenal of machine learning tools.
And that's just the start.
Oh, wow.
There are so many more algorithms out there.
Okay.
Each with its own way of learning and making predictions.
It's mind-boggling to think about all the possibilities.
Yeah.
But I'm also starting to wonder, with all this power, are there any downsides, things we need to be careful about?
That's a great question. A really important one.
Yeah.
Machine learning has the potential for a lot of good, but it's crucial that we use it responsibly.
Okay. What do you mean by that?
Can you give some examples?
Yeah. What are some things to watch out for?
One thing is the data we use to train our models.
Okay.
If the data is biased or unfair, the model will learn and perpetuate those biases.
So if we train a model to predict loan approvals using data that reflects like discriminatory practices, it might unfairly deny loans to certain groups.
Exactly. Yeah. So it's super important to curate and pre-process our data and make sure it's representative and free from harmful biases.
Sounds like a lot of responsibility comes with machine learning.
It does.
Yeah.
But it's a responsibility we can't ignore. As machine learning is used more and more, it's crucial to have these conversations about ethics and fairness.
I totally agree. This has been such an insightful conversation.
Yeah.
I feel like I'm starting to get the complexity of machine learning.
Yeah.
Both its potential and its challenges.
I'm glad to hear that. Remember, we've just scratched the surface.
Yeah.
There's so much more to learn and discover.
Right. All right, welcome back to the final part of our machine learning deep dive. Yeah. It's really amazing how much we've covered.
Yeah, it's been a lot.
From the basics of algorithms to ethical considerations. Now I'm really curious to see how this technology is being used in the real world.
Yeah.
Our Azure docs hint at some pretty amazing applications.
Oh, for sure. I mean, one that comes to mind right away is healthcare.
Okay. Yeah.
Imagine algorithms analyzing medical images.
Okay.
Like X-rays or CT scans, helping doctors detect diseases earlier and more accurately.
That's incredible. It's like having this super-powered assistant.
Yeah, yeah.
That can see things that, like, the human eye might miss.
Exactly. Machine learning is also being used to personalize treatment plans. Okay. By analyzing a patient's medical history, genetic info, lifestyle factors. Algorithms can help predict the most effective therapies.
Wow. So instead of a one-size-fits-all approach,
right,
we can tailor treatments to each person's needs.
Yeah. It has the potential to really revolutionize healthcare.
That's a game changer. But the impact goes beyond medicine.
Oh, absolutely.
Yeah.
It's also making waves in finance.
Oh, that's interesting. I wouldn't have immediately thought of finance as a field for machine learning.
But think about all that data generated in the financial world.
Yeah.
Stock prices, transactions, economic indicators. Algorithms can analyze all of that, identifying patterns and things that humans might miss.
So it's like having a digital detective
Right.
For the financial markets.
Yeah.
Sniffing out fraud.
Exactly.
Or maybe uncovering investment opportunities.
Machine learning is used for credit scoring risk assessment.
Oh, wow.
Even algorithmic trading.
Okay.
Where computers make buy and sell decisions.
That's both impressive and kind of scary. Feels like machine learning is automating things that humans used to do.
It is, and that raises questions about the future of work and skills.
Right.
But it's not just automation.
Okay.
Machine learning can also augment human capabilities.
Oh, okay.
Making us better at our jobs.
That makes sense. It's like having a tool that helps us do our jobs better.
Right.
Are there any other industries where machine learning is making a big impact?
Tons. Think about retail and e-commerce.
Okay.
Those personalized recommendations you see on Amazon or Netflix, that's machine learning.
So those, you might also like suggestions?
Yeah.
They're based on algorithms analyzing my browsing history.
Exactly. It's all about understanding your preferences.
Okay.
And predicting what you'll want next.
Those are always so accurate.
Yeah. Recommender systems are super powerful tools.
Yeah.
For increasing sales and customer satisfaction.
It's amazing to think about how machine learning is working behind the scenes in so many ways.
Yeah.
It feels like we're only just getting started.
Right. As the field keeps evolving, we'll see even more applications emerge.
What else is coming? What are you excited about?
Well, one area that's really exciting is explainable AI.
Explainable AI, what's that?
It's all about making machine learning models more transparent.
Got it.
And understandable.
Right.
Right now, a lot of models are like black boxes.
Yeah.
We know they work, but not always why they make the decisions they do.
So it's like being able to peek inside the algorithm's brain.
Exactly. Explainable AI gives us insights into the process, making it easier to trust and understand the results.
That makes sense, especially when it's used in healthcare or finance.
Yeah.
We need to understand why these algorithms are making decisions.
Absolutely. Another trend is the rise of edge computing.
Edge computing.
Okay.
This means running models directly on devices, like your phone or sensors, instead of in the cloud.
So instead of sending data to a server, the analysis happens on the device itself.
Exactly. It enables real-time decision-making.
Wow.
And opens up all these possibilities for things like autonomous vehicles.
Oh, wow.
Smart homes and wearable tech.
So the future of machine learning is making it more powerful.
Yeah.
More accessible and more understandable.
I think so.
It's a really exciting time to be alive.
Yeah.
Witnessing this revolution unfold.
It is.
This deep dive has been incredible.
I'm glad you enjoyed it.
I finally feel like I'm starting to understand machine learning.
Yeah.
Thanks for guiding me through it all.
You're welcome. Remember, this is just the beginning of your journey.
Right.
Keep exploring, keep learning, and stay curious.
I will.
There's a whole world of data out there waiting to be discovered.
This has been awesome. Thanks for listening, everyone.